Hello students, in our today's lab we will discuss about the thread. So before that I must tell you something about the process. Whenever you write a program, it's a passive entity. But when you start to run it, it becomes a active entity. Okay, so process is a program in executions. Clear? So our computer at the same time can run many processes. Okay, so that means we are running many programs into our computer. Okay, so at process is not as same as the program code, but a lot more than that. Okay, you need to maintain so many things while running a process. That means a program is execution always become a process. Attributes held by the process includes hardware state, memory, CPU, means the things then it needs to run. In the process memory, you can, when you write a program, it process memory is divided into various sections. The text would contain the data code that you have written. The data section is made up of global and static variable. Heap part basically responsible for the dynamic memory allocations. That is, it is used for dynamic memory allocation and is managed via calls to new delete malloc free, etc. Stack is used for local variables. Space on the stack is reserved for local variables when they are declared. So when you write a program, the memory part contains so many things: the data section, the text sections, the heap section, and the stack section, where they play the various different roles. And when a process, a program starts to run, it becomes a process. It needs to maintain so many things. The process states like whether it's running, it's waiting, it's blocked. Process ID means when a process starts to run, it always needs to maintain a unique ID as well as the parent ID, which is, that means from which process that new process is generated. That is called the parent ID. CPU's registers and the program counter. Program counter always holds the address of the next instruction that is going to be executed. The CPU registers also contain so many things. You know, those things, those CPU registers are basically responsible for these arithmetic calculations or various other operations. CPU scheduling means we need to schedule those processes in our queue so that every process gets chances to run. No process actually suffer for a long time, means in the waiting states, while the other process is continuing to run. Then the memory management information, for example, page table, segmentation table, etc. Needs to maintain accounting information also. That means the time limits, account number, amount of CPU used, process number, etc. Okay, that accounting information also you need to make the things going smoothly. That means no process suffers for the long time and the rest of the things. Then your status information means is device allocated, open file tables, etc. So you can see when a process starts to run, a program is running, it needs to, it has a memory part also allocated to it for holding the data part, for holding the global variables, static variables, for dynamic memory allocation. It means the memory needs to be handled differently. And also these things, this process state, process ID, CPU register, program counter, CPU scheduling, memory management, accounting information, IO status information, so many things. So it becomes then active, obviously. For that, you need to maintain so many things. Okay. And then what is thread? A thread is the path of execution within a process. You know, due to this thread, we can go for a multiple task. Multitasking can be done through this thread. So when a process is running, it's a single thread. All the programs that you have already written or you have already executed without this thread, they all were single threaded program. Means there was a single flow of control. Okay, that means it's created, then it is running, then it's finished, etc. But whenever you implement that thread concept into it, then there become the multiple flow of control, so that several tasks can be done at the same time. Okay, so a thread is sorry, a thread is also known as a lightweight process because it generates from the same process. So it need not to maintain so many things that the process was maintained during the runtime. Okay, that is why it is called a lightweight process. For example, in a browser, the browser, when you open multiple tabs, they can be considered as a different threads. Whereas in MS Word use multiple threads, one thread to format the text, another thread to process the input, etc. Okay, so thread basically we use to implement the multiple multitasking jobs in our scenarios. Process versus thread. Threads are not, a primary difference is the threads within the same process run in a shared memory space, while process run in a separate memory space. Okay, process needs to different processes need their different memory spaces to get themselves run. But the threads are not independent. Threads are not independent of one another like processes are, and as a result, threads share with other threads their code section, data section, waste resources like open file signals. But like process, a thread has its own program counter, register set, and the stack space. So in which way the threads are different? Threads have different program counter, register sets, and stack space. While in our process has a different memory spaces also. Okay, so you needs to be it needs to be clear that what is the basic difference between process and threads. That threads are not independent of one another like processes are, and as a result, threads share with other threads their code section, data section, waste resources like open files and signals. But like process, a thread has its own program counter, register set, and stack. See, here is the reason why you call it a lightweight process, because a process needs to maintain so many things, but here the threads can share with the other threads some some part of the resources, but it needs its own program counter, register set, and stack space only. Advantage of thread over process. Responsiveness. If the process is divided into multiple threads, if one thread completes its execution, then now its output can be immediately returned. So response time is a very less. Faster context switch. See, when we do the multiprocessing tasks, that means multitasking, then we are something multitasking concepts when we include in our running time, then what happens if we are having a single processor, several processes are not running at the same time, but they are switching. One process is switching to another process, then that process is switching to another process, and the switching time is so less that it appears to us that they are running simultaneously. That is the context switch time. That is called the context switch time. Is the time it needs to switch to other process. So context switch time between threads is lower. Here is also an advantage. Effective utilization of multiprocessor system. I told you we use this thread concept during the multiprocessing. So if we have multiple threads in a single process, then we can schedule multiple threads on multiple processes. This will make obviously process executions faster. With the resource sharing, resources like code, data, and files can be shared among all threads within a process. Okay. Then the communication between multiple threads is easier as threads share common address space. Okay, they only have their own this register, this stacks. Okay, and the program counter. Rest of the part they share with each other. Means the threads share with each other. Communication between multiple threads is easier as the threads share the common address space. While in process we have to follow some specific communication technique. Okay. So thread life cycles mean when a thread is generated, that is a new thread when it's running its runnable thread, it can be blocked, then it has its own waiting state, and then it's terminated. So you can see here the new one when a new thread is there, so it starts to run. It actually then reaches to the runnable state, then it's completed, then it's terminated. Okay, then the blocked, it can be blocked, okay, due to some reason. So it is then when go to the blocked state, and then waiting for any, if, if that data is needed to run, then it has to wait. So that in that way it can go to waiting state. Okay, and then it can time this processes or threads can also have its own time slot. Means that during that time only it can run. For that, it can go to the time waiting state also. So there are several states a thread can be. Means that states of the threads can be different, like new, runnable, terminated, blocked, waiting, time waiting, etc. Okay, we can create our thread. So till now I told you we were doing only the single threaded program. Now we want to create our different threads. Okay, so how we can create this thread or implement this thread into our program. So there is a two way we can extend the thread class or implement the runnable interface. If we want to implement, you have already read about learn the interface. So if we there is a runnable interface and we can implement that to create several threads in our program. So we did that become the multi-threaded program. So for that, you need to maintain three steps. If your class is intended to execute such a thread, then you can achieve this by implementing a runnable interface. You will need to follow three basic steps. First step is, as the first step, you need to implement a run method provided by a runnable interface. This method provides an entry point for the thread, and you will put your complete business logic inside this method. Okay, the run method is the main part. Following is a simple syntax of the run method. So public void run, you can call it. Second step is you will instantiate a thread object using the following constructor. That is a thread within bracket runnable thread object string thread name. Okay, thread object is an instance of a class that implements the runnable interface. Then thread name is the name given to the new thread. Okay, the first thing is that you are implementing the run method, then you are creating a thread object, and the third step is once a thread object is created, you can start it by calling a start method, which executes the call to run method. The first thing needs to be get started, then that will call the run method. So here is an example. You see it very carefully. So we are implementing the runnable interface, and using the runnable interface, we are implementing that multi-threading in our program. Okay. So the first line class runnable demo, this is a class name implement the runnable interface. And here we have a thread called T. We have declared it, and then we are having our thread name also. So it's a string. Then that constructor which is taking the string name as a parameter. So we are assigning that name to the thread name. So our thread is getting one name. Then that line will be printed, creating that thread name. Okay. Then is our run method. See, when it is created, then it will be in a running phase. Okay, so that will print, for our better understanding, that will print system.out.println running the thread name. That is how it's creating, and it will print you creating the thread, then it will print you running the thread. Then you have already learned this try and catchy block in your last class. So within that catchy try block, you are having a for loop. The thread will run 4 times. Okay, and inside that for loop you are having your thread name I. Okay, that I is the index, and then you are this thread, you have this method thread sleep, that this is a phase. Actually your thread can go to the sleep phase. Okay, 50 milliseconds or for some time. So it is created, then it's running. Okay, so when it is running, it will print that thread1 is printing. Okay, then it will go to the sleep phase. Okay, for some time, and if anything wrong occurs over there, then it will go to the catch block, and after that it will print this thread exiting. So we are creating we are running, it's going to the sleep phase, and then it is exiting means it's terminating or it finishes its job. Then we have this start method. Okay, so this start means it will starting thread name. Okay, these are the all syntaxes that you need to write to start a thread. Okay, then our main method is there. Public class test thread, this is our class, and we are having our main method. This runnable demo r1, fine, that is new thread, and then we are calling this r1 is thread. then we are calling it, okay, r1 dot start. It need to obviously start, and we are again creating another thread. There is a thread 2, so we are calling again the start method. If we run this one, you can see it will print like this. First thing was creating, then it starts to run. So starting, creating thread 1, starting thread 1, creating thread 2, r1 and r2 both two threads we have created. So creating the thread 1, creating the thread 2, starting the thread 2, then running the thread 1. It will print during the running process. It will print running thread 1. Thread, that is thread 1 4. Okay, that is actually, that will be printed due to the for loop. Inside the for loop, these things are specified. So it's running. Then it's going to its sleep phase. Then the second thread is running. Okay. So total 4, 3, 2, 1. You know the loops running for the 4 times. So you can see, first we are creating, then we are starting our threads. We have created our 2 threads over here. So first the thread 1 is created, then it's starting. Okay, then the thread 2 is created, is starting, then running thread 1. Running thread 1, when I equal to 4, thread 1 is running, then it's going to the sleep phase. So thread 2 is running, it's going to the sleep phase again. The loop continues to run, so I become 3 in this manner 4 times. So thread 1, thread 2, thread 1, thread 2. In this manner it will run. Finally, it will exit, or it will terminate. Okay, so this is in small what thread is. We are having one assignment. Do that and submit. Okay, so bye for now.